All right, hey guys. So we're moving on to 4.2, the next process of transformations on reflections. All right, so learning target, understand reflections of figures. So we could reflect a figure, we could perform compositions with reflections, and we could identify line symmetry with polygons. So the idea with reflections, think of a mirror, okay? That is a transformation that's occurring right now. You're reflecting it across a specific axis or a specific line, right? So let's read this key idea. So a reflection is a transformation that uses a line like a mirror to reflect a figure. This line is called the line of reflection. So a reflection in a line M maps every point P in the plane to a point P prime, so that for each point, one of the following properties is true. So if P is not on M, then M is perpendicular bisector of P prime, or if P is on M, then P equals P prime. All right, so it's best if we just go over the examples because it's not that difficult. So it says, example 1, graph triangle ABC with the given vertices, and then its image after reflection described. So for letter A, it says in the line where line M, y is equal to 1. So let's do that first. So we have this triangle ABC. That's going to be, I'm looking right here, triangle ABC. That is this triangle right here. They want us to reflect it where y is equal to 1, right? So we have this line, M, where y is equal to 1. This is the line. And they want us to reflect this triangle over that line. Watch this. It's actually pretty simple. So let's start off with A. I see A 2 places away from line M. So I'm going to go 2 places away from line M. That is my A prime. B is 1 place away from line M. So B prime is going to be 1 place away from line M. C is on line M. So C prime is also going to be on line M. That point. So now my image, that is my reflected image from triangle ABC. It's pretty simple. Let's look at letter B. It says in the line X, in the line N, where X is equal to 3. So we go to 3, where X is equal to 3. 1, 2, 3. That is where my line N is gonna be, right here. And we're reflecting over that line N. So triangle ABC, that was the original, the blue, that was the original image. I see that letter A is 1, 2 away from line N. So A prime is also going to be 1, 2 away from line N. I'll put this in black. So there's my first point. B is going to be 1, 2 away from line N. So B prime is also going to be 1, 2 away from line N. And then C, I see is 1 away from line N. So C prime is going to be 1 away from C prime. And now there is my reflected image. I already saw that. I know it looks crazy, but break it down. Blue was the pre-image, red is the image after the reflection. All right, so yeah, let's move on. All right, so reflecting in the line y is equal to x. So if you have line y is equal to x, that line, this is y is equal to x. That is the line, that green line, okay? So it says graph segment FG with endpoints f, -1, 2, and g, 1, 2, and its image after reflection in the y is equal to x. So I know y is equal to x is kind of kind of like it's diagonal. It's not really like horizontal or vertical. But the way I would do this is for G, point G, I'm going to go down 1 over 1, right? And then for F, let's give me my G prime. Looks like I'm going to go down 1, 2, 3, and then I got to go over 1, 2, 3. It's almost like the perpendicular, it's like the perpendicular like slope to this. That's how I sort of look at when I'm reflecting over y equals x or y is equal to negative x. Y is equal to negative x would look something like this. I don't know where my x, where's my y coordinate? Would look something like this. That would be y is equal to negative x. Okay. The easiest way to deal with the y equal to x, y is equal to negative x, if that still trips you up, are these coordinate rules for reflection. You definitely want to, it'd make things easier if you memorize these coordinate rules for y is equal to x, y is equal to negative x, and then you just automatically know how to change your coordinates based off of these coordinate rules. So this is what it means. It says, it's saying if AB is reflected in the x-axis, then its image is the point A negative B. You could do what I did. I counted, okay, x, or this coordinate is, say, 1 away from x is equal to 1, or yeah, x is equal to 1. So I got to go 1 coordinate away from x is equal to 1 for the prime image. Or you could follow these rules. So if AB is reflected in the x-axis, so let's say we have 3, 2, and it's saying reflected over the x-axis, then the image after the reflection over the x-axis is going to be 3, negative 2. Pretty simple. For the y is equal to x, y is equal to negative x, let's do that one, right? So let's do this first one right here. If that's 3, 2, and it says reflected over y is equal to negative x, then its image is going to be the point BA, which is going to be 2, 3. And then if it's reflected over y is equal to negative x, if I have 3, 2 again, and they want us to reflect over negative x, then it's going to be negative b, negative a. So negative 2, negative 3. And those are pretty easy to follow. So look at this. It says graph FG from example 2, and its image after reflection in the line y is equal to negative x. So where's my example 2? Right here. So we have our original is going to be f was negative 1, 2. Negative 1, 2. And g is going to be 1, 2. So once we graph that, we get this point right here, the blue. All right. So let's use these rules to graph over the line y is equal to negative x. So if f is negative 1, 2, I'm going to use this rule right here. Negative b, negative a. So now I have negative 2, positive 1. And that is going to be my f coordinate, or my f prime right here. And let's work on g. If g is 1, 2, this will yield to, using our rules, negative b, negative a. So I got negative 2, negative 1. And that's my new g prime. The rules make it very easy. You just got to remember them. That's a problem. All right. So reflection is rigid motion, right? We're not changing the size or the shape or any of the angles of the figure itself. Again, we're just moving it around the coordinate plane. In this case, we're reflecting it over some sort of axis. That's all we're doing. Notice all the angles are still the same. All the sides are still the same size. And the figure itself doesn't really change besides moving around on the coordinate plane. So All right, so now we have what's called a glide reflection. So a glide reflection is a transformation involving a translation followed by a reflection. Every point P is mapped to a point P double prime by the following steps. So first step, translation maps P to B prime. That's what happens here. P to P prime. Second step, a reflection in line K parallel to the direction of the translation maps P prime to P double prime. And this is where this reflection occurs. So it's a translation first, then it's a reflection, and that is a glide reflection. So let's look at these examples. Example 4, performing a glide reflection. Graph triangle ABC with the vertices. So that's what they did right here. They graphed our triangle with our vertices in its image after a glide reflection. So first we had our translation, x minus 12 and y. So we have to go back 12 for each of these coordinates, this one, and this one, but nothing changes with the y. So that's what happened first. We went back 12, y stayed the same, back 12, y stayed the same, went back 12, y stayed the same. That was the translation, right? We're not done. Now, after that translation, we need a reflection over the x-axis. So watch this. A is 1, 2 away from the x-axis, so I'm going 1, 2 away from the x-axis. B is going to be 1, 2, 3 away, so I'm going 1, 2, 3 away. And then C is just 1 away, so I'm going 1 away. And that gave us our final image. This image right here. Not difficult, right? They're just adding on to the transformations that we've already covered. All right, so identifying lines of symmetry. So figure in the plane has line symmetry when the figure can be mapped onto itself by reflection in a line. This line of reflection is a line of symmetry, such as line M at the left. Is it a butterfly? Yep, it's a butterfly. So line M is our line of symmetry. Right? We could fold this butterfly over itself and it'll be symmetric. It'll lay on top of itself perfectly. A figure can have more than one line of symmetry. So let's go to example 5. Determine whether each polygon has line symmetry. So draw the line of the symmetry and describe any reflections that map the polygon onto itself. All right, let's look at A. Does letter A have line symmetry? Yes, right? Straight down the middle. If we drew that, that's our line of symmetry. We could fold it over itself. How many does it have? Well, it only has one line of symmetry, right? We can't work on it we can't flip it like this way. That doesn't work. All right. The B, the regular hexagon. Does it have line symmetry? It does. It has a lot line of symmetry, right? There's 1, 2, 3, and then what if we cut each one of these? 4, 5, 6. Yeah, I think that's it. All right. Yep. 6 lines of symmetry are shown. Yeah, so it has 6 lines of symmetry for that regular hexagon. Finally, our parallelogram, no, it doesn't, right? We can't really flip this over here. That doesn't work. If we tried right here, that doesn't work. C, our parallelogram does not have line symmetry. All right, that's it for 4.2.